Alright, what is a wave? Well, we're going to talk about vibrations and waves and the relationship between the two things. The vibration, we can think about like a pendulum, is a repeated motion about an equilibrium point in a fixed spot in space. So the pendulum swings back and forth and back and forth. It repeats itself, and it just stays in that one location repeating itself. If that vibration is able to cause a disturbance in a medium, so imagine that pendulum is hitting the side of a glass that contains water, and so we're seeing that vibration cause a wave start in the water, then it'll create a disturbance that as the wave spreads out will repeat itself in both space and time. So I like to think about being on a boat in this situation, and you look out across the top of the water and you can see the tops of the wave. So you can see a crest of a wave followed by another crest of a wave followed by another crest of a wave, and so you can see the repeated pattern of the wave in space. If you took a picture of it, you could see the repetition. Alternatively, you could close your eyes and feel the motion of the boat as the boat went up and the boat goes down and up and down, and as a result you could feel the repetition of the wave at one point in space, but as it varies over time. So a wave is a disturbance in a medium that repeats in both space and time. It can be thought of energy being taken from a vibration and spreading out to other locations. What's the relationship between vibrations and waves? Well, if you can't tell from the discussion already, vibrations create waves in mediums. A medium is the thing that carries the wave, like a water wave, the medium would be water. In a sound wave, the medium would be air. And a vibration can also result from a wave. Imagine, for example, that the wave is finding this little buoy that's or a floating object that's sitting on the top of the water, and that floating object moves up and down and is essentially vibrating then on the top of the water in one place but over time. So vibrations can cause waves, but they can also be caused by waves. For both vibrations and waves, since they repeat in time, we can define the period of the wave as the amount of time to complete one cycle, or the frequency as the number of cycles in 1 second. If we were to plot a wave versus time, let's say this is like the height of a water wave, then we would say that the period is the amount of time it takes to complete one of its cycles. Alternatively, that would be measured in seconds. Alternatively, if we imagine then this is still time, but we go up to 1 second, the number of times it goes up and down, up and down, up and down would be the frequency. Here we can see I have 1, 2, 3 waves in that 1 second, and so we would say we have 3 cycles per 1 second, or a frequency of 3. The units here would be 1 over seconds, but when we're talking about waves we give that a special name. 1 over seconds for waves is abbreviated to hertz. So when we state a frequency, we don't typically say, 60 hertz or 61 over seconds. We would say 60 hertz. It's just an easier unit to use. So that's the difference between a vibration and a wave.